Okay, so we got to do a couple things on here. The two that we skipped, and I think we'll actually hit them later on. These I just had us graph these in the calculator, and we kind of come back to them later. So I am not going to do these right now. Alpha, we already did those, but G will come back to them later. All we did was we put them in the calculator and graph, and I believe you guys can plug into the calculator. Is that a correct assumption? Okay. Again, we'll come back to that if I believe it's important. One thing I did want to cover really quick is we went through these like last three problems. But the one I didn't finish was this one, number 3. It says write an equation of the cubic function with radical 3, negative radical 3, and 6 as zeros. And then it says multiply out, but we did not multiply it out just for sake of time last class. So we wrote it as y equals x minus root 3, x plus root 3, and then x minus 6. And now I do actually want to multiply it out. So with all the radicals, it looks super scary, but I promise it's not. When we multiply these first two together, x minus root 3 and x plus root 3, the root 3s, thank you, Red, will eventually cancel each other out. So as we go through this problem, you'll see kind of how it cleans up to be nice, pretty numbers. So I'm going to distribute this, or sorry, FOIL, x and negative root 3. So x times x is x squared. X times positive root 3 is positive root 3x. Negative root 3 times x is negative root 3x, and then negative root 3 times positive root 3 becomes a minus 3. So root 3 times root 3 is the same thing as square root of 9, and we know the square root of 9 is just 3. So as I multiply that out, that becomes minus 3. Now the cool thing here is these radical 3x, one's positive, one's negative, so they cancel each other out. So I am just left with x squared minus 3. Now I have to take that and multiply it by my x minus 6. So I still have to do x squared minus 3 and then x minus 6. I'm just kind of carrying it up here because I ran out of like down space to go. And that you still FOIL just like normal, and it will actually work out pretty nicely. It'll be x to the third minus 6x squared minus 3x and then plus 18. So I think it's pretty simple and pretty self-explanatory to put it in the equation, but I think the multiplying it out, sometimes our algebra skills with the radicals are a little shaky, so I just wanted to go over that really quick. Does that seem okay to you guys? Okay. When we get into 2.5, we're going to be doing this with i's, with imaginary numbers. And so radicals are pretty similar to that. So I wanted to cover that here. Okay, that's all I really wanted to cover in 2.3. Again, I believe I had it assigned for today, but I will collect it on Monday. I believe I see you guys on Monday. I think it's a day 3. So I'll see you guys on Monday. So if you had it done, awesome. You have no homework. If you didn't do it, you have to do that aside. We will not finish 2.4 today, so 2.4 is not due yet. Cool? That being said, we are going to get started with it, and hopefully my other class thought it was a pretty good review, so hopefully you guys will think it's review.
I got a few questions.
Yeah, what's up?
So on the one that's like F,
Letter F?
Yeah. You put all of that into Y1?
Yes. I would put all of that into Y1. Remember, depending on your calculator, when you raise it to the third power, make sure it comes back down to like a normal level. Sometimes if you forget to, it's like all of this becomes the exponent. So that's my only trick. Other than that, put it in Y1 and graph it, and you should see all the little terms.
Thank you.
You're welcome. Okay. Anybody else on that? Okay, so as we get into 2.4, we're going to do some long division practice. Do you remember doing long division with polynomials? Mm-hmm. Yeah. Good. I'm going to remind you in case you forgot, because you probably haven't done it since like, you know, this time last year in Algebra 2. When we set this up, we take the second part and we set it outside of my division sign, and then I take the first part and that goes under the division sign. Now, you need to make sure that you have every single term taken care of. So if I start with x to the third, I need an x to the third, I need an x squared, I need an x, and I need a constant. I don't have an x term here, so I'm going to put what in for x? 0x. So I'm going to write 0x and then minus 2. Yeah.
It's just like, I mean, I know you don't teach the class, but it's just something similar, you think, to what we did.
Yes, I believe you have already seen this. Mm-hmm. We're going to do synthetic division after this, which will probably look more familiar because you guys seem to like synthetic division more. I don't know if I ask you a lot to do long versus synthetic division. Normally I teach both and I'm just like, do whatever makes you happy, but I do like to go over long division. Okay, so now I ask myself, I say, okay, what times x is gonna give me x to the third? That number is gonna go right up here. And honestly, the shortcut is just, it's one exponent less than what I have. So if I wanna get to x to the third, it's just gonna be x squared. I need to remember to multiply x squared times x and times 1. So x squared times x is x to the third. X squared times -1 is minus x squared. Then I am kind of dramatic about this, but then I change all the signs on that line. So essentially it's like we're minusing it off. I minus and then I make that negative into a plus. So I change all my signs and then I put my little lines to show that I'm going to do all my minusing. The reason we have to change all of our signs is for my x cubes to cancel, I need one to be positive, one to be negative. And if you change one sign, then you have to change the other sign. So now I've got 4x squared plus x squared, so that becomes 5x squared. Carry down your next term, and then we essentially start the whole process over again. Again, I'm going to ask myself, what times x is going to give me 5x squared? 5x, very good. Plus 5x. Multiply it by everything, so I get 5x squared minus 5x. And then again, I change all of my signs, negative, positive, subtraction line. 5x squareds cancel, so I get 0x plus 5x, which is 5x, and I've got one more to carry down, minus 2. 5x minus 2, so again, now I start back over. What times x gives you 5x? That is going to be plus 5. 5 times x is 5x, and then 5 times -1 is minus 5. And then for the last time, I'm going to switch all my signs, minus, plus, and I get 3. 3 is my remainder. Do you know, like, what else do you know about remainders? We add it to the end. Sophia, did you want to add to that?
Isn't it like divided by like x minus 1 in this case?
Yep, it's by whatever was divisible, what we were dividing by. Sterling, did you want to add to that, or is that what you were going to say? Perfect. Okay, so the remainder means it does not go in evenly. There's still something left over. So my answer is going to be x squared plus 5x plus 5. And then just like all of you guys have told me, 3 goes on top, and I've got x minus 1 in the back. So it looks kind of ugly. And again, this is what represents that I have a remainder and that it's not an even 0. It's not a factor. It does not go in perfectly. All right, that's all I got. Questions? Can we do the next one? Okay. I'm going to set us up with it just in the fact that I've got an x squared minus 2. I need to give space for an x term. So I need to set it up as x squared plus 0x minus 2. And then I put everything under the radical. Or not the radical, excuse me, the long division sign. X to the 4th plus 2x to the 3rd minus 4x squared plus x minus 3. And then I keep doing my thing. What times x squared gives me x to the 4th? I'll be quiet so you guys can try yours on your own, but I'll have my work up here as you guys go. right, I've got my answer off to the right-hand side. X squared plus 2x minus 2, and then plus 5x minus 7 over x squared minus 2.
How do you know that we have to put the x squared plus 0x?
Because you need to take care of every single term. So if you just have an x squared and then a constant, you're missing an x.
Okay, so if it's like to the third, you have to have this.
Yeah. I mean, technically you don't have to add it, but you have to then leave a space every time you go through. And like, I personally can't do that. Like, I have to have a number in each line. So I like to put a 0 to hold that place.
Got it.
Good question. All right. What other questions do we have? Make sure you got that one down. Now I think we're going to synthetic division. Is that correct? Do you guys have fonder memories about that? Generally we do. Generally we do. So synthetic division is just kind of a little shortcut. And it is like it's a way to organize your numbers. It's a structure in order to do this exact same process without doing all the same steps with a little bit less work. Remember that I start with this number right here. I have to do the opposite of that. So if it says x minus 2, we're going to do positive 2. And I put him in like a little house. Next to him, I make a line of all of the coefficients of my expression. So I've got 2x to the third, 4x squared, negative 1x, and then positive 1. Don't bring any of your x's, just bring all your little coefficients. Does that seem right so far? Good. And then I skip a line and then put like a big minus line, I guess, or a equal line, just so I have some space. My answers are going to be down here. And I start by taking the first number and I bring him straight down. Then I take the number that's below the line, multiply it by the number inside the house, and I put it on the line above. Does this seem right? Okay, good. I'm going to keep talking to you like you have never seen it before, but that's all right. You guys just keep floating through it. Sometimes we get here and we're like, oh, do I add, do I subtract? I don't remember. Do whatever the sign is. So if this is a positive 4, I'm going to add them. So 4 plus 4 is 8. 2 times 8 becomes 16. Again, add them. So that becomes 15. And then last, 2 times 15 is 30. 1 plus 30 is 31. Now my answer comes from here, right? The last number is your remainder. So sometimes I put him in a box to remind myself that's the remainder. And then I have these other coefficients, 2, 8, 15. My x value that goes with 2 is 1 less than the value I started with. So if it was x to the third, now it's going to be x squared. So 2x squared plus 8x plus 15, and then plus my remainder, 31 over x minus 2. Does that seem on par for what you guys remember? Okay, let's try the next one. I think you have to hold some places. What places do you need to hold in the next one? For which one, Maggie? X squared and x. You're gonna have 2 zeros in there. So remember, oh, and what number goes in my little house?
-1.
-1. Good. Opposite signs of what it is. So I'm gonna go 1, 5, 0, 0, like Maggie told me, and then -8. All right, I'm gonna do the work, but I'll be quiet so you guys can do it as well. All right, so I got x to the third plus 4x squared minus 4x plus 4. And then I wrote plus -12 over x plus 1. You can write -12 over x plus 1. It does not matter to me. either way. I still have a remainder, I still have to take them into consideration. That's how we're doing. Cool. Okay, I've got time for one more thought. We are getting a little bit behind the other class, but that's okay. This next one says find the remainder 2 ways. Does anyone remember what's one way I can find the remainder? It's one way I can find the remainder of this expression. Good, we can do some kind of division. I'm gonna say synthetic division because that's probably what most of us will do. And let's do that out really quick. I'll put my little -1 in my house. I'll have 1, 5, -8, and 3. Carry that down. I've got 1, 4, -12, and 15. And yes, you can absolutely do long division. Synthetic division took me less than a minute though, so I like doing that. What is my remainder here? 15, very good. All right, there's one other way besides using division to find a remainder. Does anyone know what that is? It's plugging in my factor. So if I plug in -1, the answer is my remainder. Answer is remainder. So let's just plug it in really quick and then we'll explore more of that next class. So I'm going to do -1 to the third plus 5 times -1 squared minus 8 times -1 plus 3. -1 to the third is -1, right? What's -1 squared? +1, good. And +1 times 5 is just 5. What's -8 times -1? +8, and then plus 3. So 1 plus 5 is 4, 4 plus 8 is 12, and 12 plus 3 is 15. Perfect. We'll write this down next class, but basically this is what we call the factor theorem. If x plus 1 is a factor, then I can plug it in. If I get out 0, it's a factor. If I don't, then that's just my remainder. Yeah, Max. Great question. It's whatever is written right here. Whatever's in the whatever's in the denominator of your dividing from. Okay. All right, guys. I see you on Monday. Have your 2.3 homework in, and then we'll talk more after the break. Have a good break. Let me know if you need anything.